right, now let's actually prove some triangles are congruent. That's the whole purpose of this lesson. Let's practice. Okay, so knowing what theorem to use, really you have to do it based on what information they give you in the problem. What information can you find out using some of our previous theorems and definitions and things. Okay, so for this example, they want us to prove that triangle ABD is congruent to triangle EBC, and they give us that AD is parallel to EC. So AD is parallel to EC. So I'm going to come in, and whenever I have parallel lines, I'm going to start by, extending these parallel lines out. It helps me see my angles, because if I have parallel lines cut by a transversal, then I know like corresponding angles are congruent. We know alternate interior angles, so forth and so on. So I'm going to start by just extending those out so I can see those parallel lines. Okay, and they also give us that BD is congruent to BC. So we have a side, BD, this side, so blue side congruent to BC. So we're given a side. Okay, so they give us a side. So now we need to come up with the rest of it. So we don't just have one side theorem. I'm going to need some angles or more sides. I don't know anything about the other sides besides these are parallel. I don't know any other congruences. But we have two lines intersecting, and whenever two lines intersect, if we ignore these lines out here, we have two lines intersecting. Whenever have lines intersect, we have some vertical angles. So I have this angle here and this angle here. So we have those vertical angles. So let's go ahead and in our plan, let's use that as our proof. So we have angle. This angle here we'd call angle ABD, would be congruent, ABD would be congruent to EBC, angle EBC, vertical angles. Okay, vertical. So this angle and this angle. So we only have that one angle, we have that one side, so we're going to need more. We're going to need, well, if we want to use angle side angle, we're going to need another angle, or angle angle side, we're going to need another angle. I don't think side angle side will work here because I don't know two sides. And I don't see any way of coming up with one of the other sides. Okay, but we do have parallel lines here, these two parallel lines, cut by two different transversals. We have this transversal here, and we have this transversal here. Okay. But the transversal I know a lot about is the blue one, so let's go ahead and let's look at that one. So I'm going to extend this blue transversal out. Okay, and so I'm going to ignore this line. We're just looking at this blue transversal, parallel lines. Okay, and so if you notice, this angle and this angle all are alternate interior. And we know if two parallel lines are cut by a transversal, that alternate interior angles are congruent. So that angle C and this angle D are alternate interior. So angle C would be congruent to angle D because of alternate interior angles. Okay, so then I have, that's another angle. I've got this angle. So now, to know what theorem to use, we have to look at where the side's at compared to where the angles are. So if you notice, this blue side is in between the pink and the green angles. This blue side is in between the pink and the green angles, so the side is in between the angles. So the side is in between the two angles, so I can then use angle side angle for the end. Okay, so let's go ahead and let's put that into form, write it formally. Okay, so first we'll go ahead and start with our given. We know AD parallel to EC, and then we also know BD congruent to BC. That's given. So, and off to the side here, I'm going to write, that's one of our sides. Our side is right in there. That's one of our sides. Okay. And then, so second step, we used vertical angles. So we'd have angle ABD would be congruent to angle EBC. And that's because vertical angles are congruent. The name of the theorem is the vertical angles congruence theorem, but just saying vertical angles are congruent is shorter. So there's an angle. And then last, we had our alternate interior angles. So we'll go angle C congruent to angle D. And that would be what? The alternate interior angles theorem? And so there's another angle. And so then we look at the picture, the side is in between the two angles that we know. So my last step then would be saying, okay, triangle ABD would be congruent to triangle EBC by the angle side angle congruence theorem. Okay, have you noticed we use vertical angles a lot? Okay, we also use parallel lines cut by a transversal a lot. So those are really important theorems to know. Okay, all right, we've got one more. Okay, so here we want to write a proof. Okay, we want to prove that triangle HFG here is congruent to triangle GKH. Okay, they tell us that HF is parallel to GK. So again, I'm going to come in, I'm going to take my parallel lines here, I'm going to extend them out. So that way, if I need to draw transversals, then it makes it easier for me to see that transversal. So there's my parallel lines. Okay. So they tell us they're parallel. We know angle F and angle K are right angles. Okay. So now let's look at the picture and see what else we know. Let's see. In this triangle, one of the sides is GH. In this triangle, the other side is GH. Okay. But again, HG and GH switch spots. Okay. So we could use reflexive there. We know HG would be congruent to GH. So we know this side we can come in and notch it. This side is going to be congruent to itself, so let's go ahead and let's highlight that one, so that side. Okay, so, all right, so let's think here, we have a right angle. So in my plan, I know we have a right angle, which then implies it's a right triangle, which means I could use the HL theorem, maybe, okay? And they tell us the hypotenuse here, right? This is the hypotenuse, the long side opposite the 90-degree angle. But I don't know any of these legs. Like, I don't know that one. I know they're parallel, but I don't know congruence. So I'm thinking HL won't work because I don't know a leg. I don't know a leg. Hey, but we do know angle F would be congruent to angle K because they're both right angles. That's our right angle congruence theorem. They're both right angles. Angle F is congruent to angle K. If they're both right angles, then they're congruent. The right angles congruence theorem, if you remember, it says that all right angles are congruent. Okay. All right, so we have one angle. So let's mark that angle. Let's mark that angle green. We've got this angle and this angle. So let's see if we can't get another angle somewhere. Well, parallel lines, that's a good indicator. We're either going to use alternate interior or corresponding or something along those lines. And just like we did with this one, we took the transversal we knew the most about, that blue transversal, and extended it. Let's do that here. Let's take this blue transversal here and let's extend it. Okay, let's extend it out. So if we're just looking at this transversal here, parallel line, transversal, well, we can look at this angle, parallel line to transversal, and this angle. These two angles are alternate interior. So I know they're congruent if we have those parallel lines. So we'd have angle KGH congruent to angle, we want KGH, so we'd go FHG, alternate interior. Okay, so we have those angles. So let's go ahead and let's mark those pink. Okay, but now, if we look at like this triangle, we have green triangle, pink triangle, then blue side. Here we have green angle, pink angle, blue side. The blue side isn't in between the two colored angles. So that tells me that my side isn't between my two angles. So my side, we're going angle, angle, then side, angle, angle, then side. So that would be the angle, angle, side congruence theorem based on that information. Okay, so let's go ahead and let's put this in my proof. Let's start with our given, again, HF, parallel to GK, and then angle F and angle K are right angles. Okay, so that's given. Okay, and then we went to say that ARE, right angles. We did HG is congruent to GH. Remember, saying something is congruent to itself is the reflexive property. And this would be the reflexive property of congruence. Okay, all right. And then we know angle F and K are right angles, so that tells me they're congruent. By the right angles congruence theorem. Okay, so let's see, this was a side. We had a side down here, and then this was an angle. We had an angle there, angle F and angle K. So then after that, we did alternate interior angles. So angle KGH, congruent to angle FHG. Reason for here, alternate interior angles theorem. Okay, so there's our alternate interior angles theorem, so there's another angle. And since the side that we know isn't in between the two angles that we know, it's a non-included side, then we know congruence by angle, angle side. HFG, congruent to triangle GKH, by the angle, angle side congruence theorem. Okay, all right. Now if you notice, down here at the bottom, I've included a nice little table with pretty little pictures that help us basically sum up all of our different shortcuts for proving triangles congruent. Again, remember, these are shortcuts. Hey, we can always go back to proving all 6 parts of one triangle congruent to all 6 parts of another. Hey, but there's really no point when we can use these nice little shortcuts. We have our side and angle side, again, included angle in there. We have our side, side, side. We have our HL theorem, again, that only applies for right triangles only. We have our angle side angle, so we have that nice included side there. And then we have our angle, angle side. That's the non-included side. Okay, so jot down your practice and good luck.